Hello friends and my dear students, I welcome you all to my channel. If you are new to my channel and not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I will highly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. This is part 6 of video series of videos on the chapter linear equations in one variable, where I will solve the test paper 7, which is based on the chapter algebraic expressions and linear equations in one variable. It is highly advisable that you before solving the test paper 7, you should have a good understanding of the chapter on algebraic expressions and linear equations in one variable. If you have not studied these two chapters, then you can watch my videos in the same playlist where I have thoroughly discussed and covered the concepts of algebraic expressions and linear equations with quite a bit of solving of problems. It will help, my videos will help you understand the basic concepts and will give you a good foundation for solving this test paper 7. So let's get started with this video. Okay, so I have the test paper on the left hand side, and on the right hand side I will solve the problems. I hope you can see the questions properly. I have I've zoomed in quite a bit. Okay, so let's solve the problems. The first one says the first problem says evaluate x cube plus y cube plus z cube. The algebraic expression given is x cube plus y cube plus z cube minus 3xyz. It is asking to evaluate this expression for x equals to minus 2, y equals to minus 1, and z equals to 3. Okay, so for evaluating an algebraic expression for given values of the variables, we just substitute the given values of the variables in the algebraic expression. So after substituting the values of given values of x, y, z in the algebraic expression, it becomes x cube is minus 2 cube, y cube means minus 1 cube, z cube means z is 3, so 3 cube, and minus 3xyz, x is minus 2, y is minus 1, and z is 3. Okay, so now we have to evaluate this new arithmetic expression. Minus 2 cube is this is minus 2 cube. This is a concept of exponents. I hope you have you have studied and completed the chapter on exponents. I have already covered that chapter thoroughly. If you can watch, you can also watch my videos in the same playlist on the exponents. You will get a good idea and foundation. So minus 2 cube is minus 8, because the base minus 2 is negative. 2 cube is 8. The base minus 2 is negative, but the power is odd. So if for an exponent for a number in an exponential form, if the power is odd and the base is negative, the final result, the final value is negative. So this will be a negative of 2 cube, that is minus 8. Similarly, for this one, minus 1 cube, it will be minus 1, that is negative of 1 cube, that is minus 1. 3 cube is 27, and minus 3 into minus 2 into minus 1 into 3 is nothing but 3 into 2 into 1, that is 9 into 2, that is 18. If we further simplify this becomes minus 9, 27 minus 9 minus 18, that is 27, and this is 0. So the answer is 0. So the value of this given algebraic expression for given values of x is 0. Okay, let's do question number 2. It says write the coefficient of x in each of the following. So we have three parts, and for each of the three parts we are given some term. We have to find the coefficient of x in each of the terms. So first term is minus 5xy. We know that the coefficient of x in this term will be everything that is left if we remove x from this term. So coefficient of x will be from the term minus 5xy. If you remove x, if you ignore x, whatever remaining is the coefficient, that is minus 5y. Okay. For part 2, the given term is 2xy square z. Here, if you the coefficient of x will be everything in the term if you just ignore the x. If you ignore the factor x, whatever remaining is the coefficient. So that is 2y square z. For let's see the part 3, the term given is minus 3 by 2 abx. Okay. So abx. So for this the coefficient of x will be everything in the term if we excluding the x part, that is the factor x, that is minus 3 by 2 ab. Okay, that is question number 2. Now let's do question number 3. It says subtract a given expression is given, a given algebraic expression is given, so subtract this from this. So it is asking, so let's do it in a very systematic way. So let's say the first algebraic expression is a. It is given to be x square minus 2xy plus 5y square minus 4. And the second algebraic expression given is, let's say that is b. It is 4xy minus 5x square minus y square plus c, and we have to find subtract the first algebraic expression from the second. So we have to find b minus a. Now while subtracting, so this is while subtracting subtraction and addition of algebraic expressions, where the algebraic expressions has multiple terms, it is always convenient and recommended to use proper grouping symbols. So b, I will write it as 4xy minus 5. I will write it inside a grouping symbol, plus 6. Now minus a, the algebraic expression a, I will also write it inside a grouping symbol. So x square minus 2xy. Grouping symbols, if we use properly grouping symbols, the solution looks clean, and you will also not make any mistakes. So now if we evaluate this, simplify this, for the first grouping symbol we can just open it because there is no negative sign in front of it. So it becomes 4xy minus 5x square minus y square plus 6. But to remove or open the second grouping symbol, there is a negative sign in front of it. So we will open it, but all the terms inside the grouping symbol, their sign will change. So x square will become minus x square, minus 2xy will become plus 2xy, plus 5y square will become minus 5y square, and minus 4 will become plus 4. So now we have to further simplify this algebraic expression by adding the like terms. So let's add the like terms xy, the terms that have a literal coefficient xy. What is the literal coefficient of a term? It is the variable part, that is the part except the constant part. and constant part of a term is known as the coefficient or numerical coefficient. So if we consider the term containing the literal coefficient xy, we have 4xy and plus 2xy. So let's first group together the like terms, 4x plus 2y. Then let's group together the like terms having literal coefficient x square. So we have minus 5x square and 5x square. So this is, we have the terms minus 5x square and minus x square. Now let's group the terms with the literal coefficient y square. So we have a minus 5y square and minus y square. Okay, and finally we have the constant terms. They are 6 plus 4. Now if we add the like terms, all the like terms, we get 4xy, sorry, this was xy. Okay, so 4xy plus 2xy is 6xy, and minus 5x square minus x square is minus 6x square, so this becomes minus 6x square. Minus 5y square minus y square is minus 6x square minus 6y square, so that becomes minus 6y square. And finally the constant term 6 plus 4 is 10. So this is the final, this is the simplified algebraic expression. I mean, this is the algebraic expression when we subtract A from B. Okay, let's do question number 4. Question number 4. How much less is x square minus 2xy plus 3y square than? Okay, so let's assume for this kind of problems, when it is where two or more algebraic expressions are involved, it is often convenient to let those algebraic expressions with some capital letters. It is easy for it is easy for computation and readability, for better readability. So let's say it is asking how much less is this expression than this other expression. So let the first algebraic given expression is A, so that is x square minus 2xy plus 3y square and the second algebraic expression given is 2x square minus 3y square plus xy. So now it is asking how much less is A than B. How much less is A than B? So definitely it means A is less and A is smaller and B is larger. So we can say that A is less than B by B minus A. This is a very fundamental concept for any number. Since these all these algebraic expressions, all the variables are numbers, so eventually these algebraic expressions will ultimately represent some numbers. So we know that all mathematical operations which are applicable to numbers like whole numbers, integers, fractions, decimals, they are also applicable to algebraic expressions. So we know that for any two numbers A and B, if A is greater than B, then we know that if A is smaller than B, then A is smaller than B by B minus A. It is difference of the greater number than it is the difference of the greater number and the smaller number. So in this problem we know that algebraic expression A is less than algebraic expression B by B minus A. So we have to find B minus A. So B minus A is better to use grouping symbol 2x square minus 3y square plus xy minus a, which is x square minus 2xy plus 3y square. Now we have to simplify this algebraic expression. We can remove or delete the first grouping symbol because we do not have any negative sign before it. So it becomes 2x square minus 3y square plus xy. But when to remove the second grouping symbol, we see there is a negative sign before it. So we have to change the sign of all the terms inside the grouping symbol. So it becomes, when we remove the open the grouping symbol, it becomes minus x square plus 2xy and minus 3y square. Now we will group together all the like terms. So 2x square minus x square, then we have minus 3y square and then we have plus xy plus 2xy, and there are no constant terms. So we have grouped all the like terms. Then now we will have to add the like terms. 2x square minus x square is x square, minus 3y square is minus 6y square, and xy plus 2xy is 3xy. So this is the answer. This is so the algebraic expression A is less by algebraic expression B by x square minus 6y square plus 3xy. Okay. Question number 5. Question number 5. Question number 5 says find the product of. Okay, so 3 terms are given. We have to find the product of those 3 terms, or a term, algebraic expression. A term means a monomial. So we have to find the product of 3 monomial. The first one is 3 by 5 a b c cube. The second one is minus 25 by 12 a cube b square, and the third one is minus 8 b cube c. Now how do we do product of monomials, 2 or more? We first find the product of all the coefficients of the monomials. Coefficient means the numerical coefficients of the monomials. So we first group together or find the product of all the numerical coefficients or the coefficients of the monomials. So that becomes 3 by 5 multiplied by minus 25 by 12 multiplied by minus 8. So this is the coefficient of the final product. Now we will find the product of all the literal coefficients of the monomials. For the first one, the literal coefficient is ab c cube. For the second term, the literal coefficient is a cube b square. What is literal coefficient of a term or a monomial? It is everything except the coefficient or except the numerical coefficient. And the third literal coefficient of the third monomial is b cube c. Now if we do the product of all the coefficients, how much it becomes? It becomes 5 cancels 5. It becomes minus minus cancels out. So 5 multiplied by 24 2. So this is 2. And now when we do the products of the literal coefficients, multiple literal coefficients, we will group together the similar literals. So we have, from the first literal coefficient we have a, from the second literal coefficient we have a cube, and from the third literal coefficient we do not have any a, so we have a into a cube. Then we will consider group together the literal variable b. So from the first literal coefficient we get b, from the second literal coefficient we get b square, and from the third literal coefficient we get b cube. Similarly for c, from the first literal coefficient we get c cube, and from the third literal coefficient we get c. Now 5 into 10 is 5 into 2 is 10. A into a cube is a to the power 4. B into b square into b cube is, so now we are applying the concept of exponents. So we know that a to the, from the laws of exponents, a to the power m multiplied by a to the power n is, when the base is same, when we have different powers or exponent, we just add up the powers, is m plus n. We are applying this concept. So a into a cube is a to the power 4 plus 1 plus 3. B into b cube, b square into b cube is b to the power 1 plus 2 plus 3, that is 6. Similarly, c cube into c is c to the power 4. So this is the product, answer, product of all the given terms or monomials. Okay. So while I am solving the problem, you can pause the video and try yourself, and if you can't solve it, you can see my solution, and also you can pause the video and take screenshot for your future reference. Okay. Problem number 6. Problem number 6 is simplify. It is asking to simplify a given algebraic expression, which is 3a plus 4, product of 3a plus 4 and 2a minus 3 plus 5a minus 4 multiplied by a plus 2. We have to simplify these algebraic expressions. So the first one is the product of two binomials. Also the second one is product of two binomials, and we know how we do product of two binomials. We use the distributive law of multiplication over addition or subtraction. So if you do it step by step, it will be, you first so this is 3a plus 4 multiplied by 2a, and then minus, since we have 2a minus 3, we have to distribute multiplication over subtraction. So this is 3a plus 4 multiplied by 3. So this becomes, so after distributing multiplication over the subtraction, this becomes this. So this is the first product, the result with the first product. Always use proper grouping symbols for better readability, and also it will help you to not make any mistakes. Plus we have the second one. If we do the multiplication product of the two binomials using the distributive law of multiplication over addition, it will be 5a minus 4 multiplied by a plus 5a minus 4 multiplied by 2. Okay. So let's simplify the term expression inside the first square bracket. Now we have to multiply 2a with 3a plus 4. So it's a product of monomial and a binomial. So this will be 6a square plus 8a. 6a square plus 8a, and then we have minus, then the product of a monomial 3 with the binomial 3a plus 4, that is 9a plus 12. Okay. Now let's simplify further the expression inside the second square bracket. We have a into 5a minus 4, that is 5a square minus 4a. So we are again using multiplicative distributive law of multiplication over subtraction or addition. Now this is 10a minus 8. Okay. Now we will remove the inner grouping symbols inside both the square brackets. So for the first square bracket, the first grouping symbol can be removed easily because it doesn't have any negative sign before it. So this is 6a square plus 8a, but to remove the second inner grouping symbol, there is a negative sign, so its terms will the sign of its terms will change, so it will be minus 9a minus 12. Similarly, for the second square bracket, if we can remove the first inner grouping symbol without any problem, 5a square minus 4a, and the second inner grouping symbol will also just open because it has no negative sign before it. So this is 10a minus 8. Now for the first square bracket, we have to simplify the algebraic expression inside it, so that all the like terms are added. So if we add the like terms, 8a minus 9a, it becomes 6a square minus a plus 12. Similarly, for the second square bracket, in algebraic expression for the second square bracket, we have to add the like terms, that is minus 4a and plus 10a. So minus 4a plus 10a is plus 6a. So now we can remove both the square bracket grouping symbols without any problem, because they both none of them have negative sign before them. So we can simply remove them. So 6a square minus a plus 12 plus 5a square plus 6a minus 8. Now again finally we have to add the like terms. So let's group the like terms. We have 6a square plus 5a square. We have 6a and minus a, and finally we have the constant terms 12 minus 8. Now after adding the like terms, it becomes 6a square plus 5a square is 11a square. 6a minus a is 5a, and 12 minus 8 is 4. So this is the simplified algebraic expression. Okay, this was question number 6. Let's do question number 7. Question number 7 says it is a solve. So we have to solve the linear equation. The linear equation is given 3x by 10 plus 2x by 5 equals 7x by 25 plus 29 by 25. So we see all the terms are in the rational form, and all the denominators of all the terms are integers, and so it's better to that we find the LCM of all the denominators, and we multiply both the LHS and RHS with that LCM. So LCM of 10, 5, 25 we have to find. Let's quickly find what is the LCM of 10, 5 and 25. So first we will divide with the least prime number, that is we can divide by 5, 2, 1, 5, and so this is, so the LCM is 5 into 5 into 2, that is 50. The LCM is 50. Okay, so now multiplying both sides by 50, this implies 50 multiplied by the LHS, that is 3x by 10 plus 2x by 5 equals 50 multiplied with RHS, that is 7x by 25 plus 29 by 25. Now if we do the products, simplify, that is open the brackets in both sides, LHS and RHS, we have 50 into, so we have to find the product of 50 and the binomial 3x by 10 plus 2x by 5 using the distributive law of multiplication over addition. So this becomes 15x, 50 into 3x by 10 is 15x plus 50 into 2x by 5 is 20x equals, if you do the product of the right hand side, it is 50 into 7x by 25, that is 14x, plus 50 into 29 by 25 is 58. So now we will bring all the variable terms, that is the terms containing x, to the left hand side and all the constant terms to the right hand side, and we get 15x plus 20x minus 14x equals 58. Now if we add all the variable terms in the left hand side, it becomes 15x plus 20x is 35x, 15x minus 14x is x, and x plus 20x is 21x. So 21x is 58. It is not dividing properly. Let me check if I did any calculation mistake or not. So 7x by 25, 29 by 25, the LCM is 10, 5 and 25, LCM is 50. Okay, so we multiply both sides by 50 and it becomes 15x plus 10, 20x, okay, equals 50 into 7x by 25 is 14x plus 2, 58. Okay, 58. Now 15x plus 20x minus 14x equals to 58, and x plus, yeah, it is fine. So we got 21x equals to 58. This implies x equals to 58 by 21. And we cannot further reduce it further. So this is the answer, 58 by 21. Uh, 58 by 21. Okay. If I do any calculation mistakes, please do let me know in the comment section. I will appreciate that, because I am prone to make mistakes, but I have checked it once, checked it twice, and it seems to be correct. Okay, let's do question number 8. Question number 8 is solve. It is again solve 0.5x plus x by 3 equals 0.25x plus 7. Now this equation has both decimals, that is the variable terms have coefficient as decimal numbers, that is 0.5x and 0.25x, and also it has some fractional form, that is x by 3. Now you probably might be thinking that you will since the fractional part, that is the rational form x by 3 has denominator 3, you will multiply both sides by 3. You can do that, no problem, but yes, if you do that, then you will get rid of the rational form, but okay, let's do that. But without multiplying by 3, you can simply bring the all the x terms to the left hand side and you can add them up, but you should be comfortable with the addition and subtraction of the rational numbers or fractions and decimals. So let's multiply both sides by 3, multiplying both sides. Another way, whenever you have a decimal number, either in the as a numerical coefficient of the variable term or as a constant term, you can multiply both the LHS and RHS with a number which is power of 10, and that power will be the maximum number of decimal places in all the decimal constants or the decimal coefficient. That way also you can get rid of decimal numbers. For example, in this example, I see 0.25, it has the maximum decimal places which is 2, but if I would like to multiply both sides by 10 to the power 2, that is 100, but if I multiply 100 with x by 3, it is not giving a nice form, nice number, so that will not really help. So I think it's better we multiply both sides by 3. We are multiplying both the LHS and the RHS with the non-zero number 3. So while solving a linear equation, we know there is a rule that we can multiply both the LHS and the RHS with a non-zero number, and that doesn't change the equality. Now if we do the product of both the LHS, product on both the LHS and RHS and open the brackets, we get 3 into 0.5x is 1.5x plus 3 into x by 3 is x. On the right hand side we get 3 into 0.25x is 0.75x, and 3 into 7 is 21. Okay, so now we will bring all the x terms to the left hand side and keep all the constant terms to the right hand side. It becomes 1.5x plus x minus 0.75x equals 21. Now if we add up all the x terms on the left hand side, it is 1.5 plus 1 minus 0.75x. So when you on the left hand side we have all like terms where the literal coefficient is, we have all the like terms. And how do you add like terms? We just add up the coefficients of the like terms, and then the result will be that coefficient, the product of that coefficient and the literal coefficient of the like terms. Here the literal coefficient of the like terms on the left hand side is x. So we just added up all the coefficients of the terms. So that is 1.5 plus 1 minus 0.75. So this we have 21. Now if we do the addition of all the coefficient, it becomes 1 plus 1.5 plus 1 is 2.5, and 2.5 minus 0.75. So this is 2.5 minus 0.75x equals 21. So how do we subtract two decimal numbers? We have studied in the chapter decimal numbers how to subtract two decimal numbers. So first we write the bigger decimal numbers, that is 2.5, and then first we convert decimal numbers. Okay, decimal numbers. Okay, first we convert all the decimal numbers to like decimals. What are like decimals? Like decimals have the same number of decimal places. So since 0.75 the decimal places is 2, we will write 2.5 as 2.50. So we know that we can add any number of zeros to the extreme right of a decimal number. It makes no change. The decimal number remains unchanged. So now we will write the smaller decimal number just below the greater decimal number in the column wise, and we can add as 0 since there is 0.575. so now we do the subtraction just like whole numbers, and this becomes 5 and 7 and 1. So we are subtracting basically 250 from 250, even though the decimal points are there. So how do we do subtraction of two decimal numbers? We write the larger decimal numbers first. First we convert the two decimal numbers to be like decimal numbers, that is they will have the same number of decimal places. So now then we write the larger decimal number, which is 2.50. Then we write the smaller decimal number, which is 0.75 below the larger decimal number in column wise, so that all the digits of the same places are in the same column. Now we do the subtraction, ignoring the decimal point. We do the subtraction just like whole numbers, that is we will subtract 75 from 250, which comes out to be 175. Now we have to put the decimal point. The decimal point will be such that the decimal point in the result will be we have to put the decimal point so that the decimal places becomes the decimal places of the two decimal numbers that we are subtracting, which is 2. So we have to put the decimal point in 175 so that the decimal places becomes 2, which means we have to put the decimal point after 2 digits from the right hand side, so 1.75. So we have 1.75x equals 21. Now this implies x equals to 21 divided by 1.75. This equals division. Now 1.75 decimal, we can convert it to rational form or fraction form as 175 divided by 100. So now we have 21 divided by 175 by 100. This is nothing but 21 multiplied by the reciprocal of 175 by 100, which is 100 by 175. Now I think 175 will be divided by 7. So this will be, if you divide by 7, 175 by 7, this is 2 and 5, and 21 divided by 7 is 3, and 25 divides 100, 4. So this is 12. So x is 12. X is 12. This is the solution of the given linear equation. So since there was one term x by 3 was in the rational form and the denominator was constant phi, we multiplied both sides by 3 to get rid of the rational form, and then we proceeded by doing the product of 3 on both sides, opening the brackets and bringing the variable terms to the left hand side and the constant terms to the right hand side, and further simplification we get x equals to 12. Okay, let's see question number 9. This is a word problem, I guess. Okay, the sum of two consecutive odd numbers is 68. Find the numbers. Okay, the sum of two consecutive odd integer numbers is 68. Find the numbers. Okay, so we know that if we let the smaller, that is the first odd integer, be x. So if we know that for two unknown consecutive numbers, if we know one, then we can easily know the other, because if the first consecutive number is let's say if x, then the second consecutive odd number will be x plus 2. Or if we have considered the larger odd number is x, then the smaller consecutive odd number will be x minus 2. So let the smaller we are assuming the smaller odd integer be x. Therefore, the larger consecutive odd integer is x plus 2. Now it is also given the sum of the two consecutive odd integers is 68. So this implies x plus 2. X plus 2 is the sum of the two consecutive odd integers in terms of the variable x, and the sum is given to be 68. So now we have to solve this linear equation. We keep the variable terms to the left hand side and we bring all the constant terms to the right hand side. It becomes x plus x equals 68 minus 2. This implies 2x equals 66. This implies x equals 66 by 2, that is 33. So 33 is the smaller odd integer. So consecutive odd integers are x is 33, which is the smaller odd integer. So the next consecutive odd integer will be 33 plus 2, that is 35. So 33 and 35 is the answer. Okay. The next is question number 10, which is also a word problem. Question number 10. It says Renu's father is thrice as old as Renu. After 12 years, he will be just twice his daughter. Find their present ages. Okay, Renu's father is thrice as old as Renu. Okay, so let's consider. Let the present age. The present age. So the two unknowns are the age of Renu and her father. But there is a relation given that Renu's father is thrice as old as Renu. So if we assume that a present age of Renu as x, we will know that the present age of father is 3x. So let the present age of Renu be x. Therefore, present age of father equals thrice of x. What is x? X is present age of Renu. So present age of father is thrice present age of Renu, that is thrice of x, which is 3x. Now it says that after 12 years, okay, so let's find out after 12 years, age of Renu will be x plus 12. Present age of Renu we have assumed to be x. So after 12 years, age of Renu will be x plus 12. Similarly, after 12 years, age of father will be, the present age of father is thrice x. So after 12 years, age of father will be 3x plus 12. Now it's saying that after 12 years, he will be just twice his daughter. That is, father's age will be twice his daughter. So now from this condition, we can say that 3x plus 12, which is father's age after 12 years, equals twice the age of daughter after 12 years. So that will be 2 into x plus 12. So this is the linear equation we have formed. Now we have to solve this. So if we remove the grouping symbol on the right hand side, open the grouping symbol on the right hand side, by doing the product, we get 2x plus 24. Now if we bring all the variable terms, x terms, to the left hand side and the constant terms to the right hand side, we get 3x minus 2x equals 24 minus 12. If we simplify further, we get 3x minus 2x is x. On the right hand side, 24 minus 12 is 12. So we got x as 12, which is the present age of Renu. So therefore, present age of Renu is 12 years and present age of father will be 3x and x is 12, that is 3 into 12, that is 36 years. Okay. Okay, this was all section A. Okay, so this was all questions of section A. Now we will solve problems of section B. So while you are watching my videos, and if you are stuck at any problem, you can see my solution, pause the video and take a screenshot for your reference. So now section B. Section B, mark tick against the correct answer in each of the following. So it's a section B, questions are MCQ. We have to select the correct choice. Okay, so let's see question number 11 in section B. It's saying, so we have to solve. An equation is given, 2x plus 5 by 3 equals 1 by 4, x 1 by 4x plus 4, then find x. That is, it is asking to solve x from this linear equation. Since we see there are two fractions, 5 by 3 and 1 by 4, we would like to multiply both sides with the LCM of 3 and 4, that is 12. So multiplying both sides by 12. Why 12? It is the LCM of 3 and 4, and 3 and 4 are the denominators of the two fraction terms. We get 12 into 2x plus 5 by 3 equals 12 into 1 by 4x plus 4. Now if we open the brackets and do the products on both sides, we get 24x plus 20 equals 3x plus 48. Now we bring all the x terms, variable terms, to the left hand side and all the constant terms to the right hand side. By using transposition of terms, we get 24x minus 3x equals 48 minus 20. Now further simplifying the terms on both sides, we get 24x minus 3x is 21x equals 48 minus 20 is 28. This implies x equals 28 divided by 21. This after cancellation, further reducing this rational number, we get it is 4 by 3. So x is 4 by 3. So 21 when divided by 7 is 3, and 21 when divided by 7 is 4. Okay, so x is 4 by 3. Oh, so we have to select the correct choice. So choice is D. Okay. Question number 12 is also solving a linear equation, and the linear equation given the linear equation given is x minus 2, x by 2 minus x by 3 equals 5. Then find the value of x. So we have to solve x from this linear equation. So this is simple. We have to just find x by 2 minus x by 3. This is nothing but half minus 1 by 3 x into x equals to 5, and 1 half minus 1 by 3 is 1 by 6. So this is 1 by 6, x equals 5. This implies x is 5 divided by 1 by 6. This is 5 multiplied by the reciprocal of 1 by 6, that is 6. This is 30. So x is 30. So the correct choice is D. Okay. Question number 13 is also solving a linear equation. The linear equation given is x minus 2 by 3 equals 2x minus 1 by 3 minus 1. Okay. Then find the value of x. So we have to solve this equation. We see that two terms are having fraction in the form of fraction, and they both have denominator 3. So we will multiply both sides, multiplying both sides by 3. We get 3 multiplied by the LHS, which is x minus 2 by 3, equals 3 into RHS, that is 2x minus 1 by 3 and minus 1. Now if we open the brackets and do the products on both the LHS and RHS, we get x minus 2 equals 2x minus 1 minus 1. So I am not in details explaining how I am doing the product of, on the left hand side, 3 into x minus 2 by 3. So x minus 2 by 3 is a monomial, and 3 is also a monomial. So how the product will be 3 will cancel out, so the LHS will be x minus 2. And the right hand side we have to use the right hand side is the product of 3, which is a monomial, and a binomial, which is the 2x minus 1 by 3 minus 1, that is a binomial. So we know how to multiply a monomial and a binomial using the distributive law of multiplication over subtraction. So we have this. Now if we open the brackets on the LHS, on the RHS, this is 2x minus 1 minus, and there is also minus 1, so this becomes okay, let me do it step by step. Now we will bring all the variable terms, that is the x terms, on the left hand side, and all the constant terms to the right hand side, and this become x minus 2x equals minus 1 plus 2. Now this implies x minus 2x is minus x equals minus 1 plus 2 is 0. So this implies x is 0. So x is 0. X is 0 and there is no choice, x is 0. Okay, so I did some mistake, let me check. X minus 2 by 3 equals 2x minus 1 by 3 minus 1. So if we multiply both sides by 3, we get x minus 2 equals 2x minus, okay, I did some mistake. This will be not 1, this will be 3. 3, this will be 3. So this will be 3, and this will be, no, this that was right. This one, this will be 3, and this will not be 0, it will be minus 4 plus 2. Minus 4 plus 2 is minus 2. This implies minus x is minus 2, so x is 2. X is actually minus 1 divided by minus 1, this is 2. So the choice is correct choice is A. Okay, let's see question number 14. Question number 14, it's a word problem. A number when multiplied by 4 is increased by 54, the number is, okay. So it is saying that when a number when multiplied by 4 is increased by 54, increased by 54 means it becomes a more by 54. Okay, so let the number be, for this kind of word problem it is very essential that we understand the language of the problem, what exactly it is saying, and all the word statements related to mathematical operations and relations, that is less than, greater than, increased by, decreased by, twice, thrice, all these terms you have to be very familiar with, and you have to be very comfortable in translating those phrases into mathematical expressions or algebraic expressions. So let the number be x. Now so a number when multiplied by 4, so x multiplied by 4 equals 4x. Okay, now this 4x, it is saying that when the number x is multiplied by 4, we got 4x. Now it is saying that this 4x is greater than the original number x by 54. So now it is saying that 4x is greater than x by 54. That is what it means when it says a number when multiplied by 4 is increased by 54. Is increased by 54. So 4x is greater than x by 54. We can so this implies, if we translate the fact that the original number x got increased by 54 when it was multiplied by 4. So okay, let's do one thing. So x increased by, x was the original number, x increased by 54 equals x plus 54. I mean, if we increase x by 54, it becomes x plus 54, and this will be the same as the number multiplied by 4, because it says that a number when multiplied by 4 is increased by 54. So from here we can say that x plus 54 equals 4x. Now this is the linear equation we got. From here, if we bring the x terms, variable terms, to the left hand side and the constant terms to the right hand side, we get x minus 4x equals minus 54. This implies x minus 4x is minus 3x. Minus 3x equals minus 54. This implies x equals minus 54 divided by minus 3. This is 18. So the number is 18. The number is 18. So the correct answer is, the choice is C. Okay, let's do question number 15. Let's do question number 15. It says two complementary angles differ by 14 degree. The larger angle is. So two complementary angles, two angles are said to be complementary when their sum is 90 degree. So from trigonometry, we know that two angles A and B are said to be complementary to each other, said to be complementary angles when they add up or when their sum is 90 degree. So since it is asking to find the larger angle, we will assume let the larger angle be x. X degree, I'm ignoring the degree part. I hope it's understood. So let the larger angle be x. We know, since we know that the other angle, the smaller angle, and this angle x are complementary to each other, their sum will be 180 degree, 90 degree. So we can say smaller angle, smaller complementary angle is 90 minus x. So if one angle is x and if the other angle has to be 90 minus x, so that their sum is 90. So we have got the two angles, complementary angles, is in terms of x. One is x and the other one is, the larger one is x and the smaller one is 90 minus x. Now it is saying that the difference of the two complementary angles is 14 degree. Therefore, as per the problem, the difference means the difference from the larger angle to from the smaller angle, the difference of the larger angle and the smaller angle. So larger angle is x and the smaller angle is 90 minus x. This is the difference, and this should be equal to 10 as per the given problem. So this is the linear equation we got. We have to solve this. Now when we open the bracket, we see there is a negative sign in front of it. So its terms, the sign of its terms will change. So this will become x minus 90 and plus x equals 10. Now we will bring the constant terms, all constant terms, to the right hand side, and this becomes x plus x equals 10 plus 90. After further simplification, we get, if we add up the terms in both the sides, we get x plus x is 2x and 10 plus 90 is 100. So we got 2x equals to 100. This implies x equals 100 by 2. This is 50. So 50 is the larger angle. 50 is the larger angle. That is what the question has asked. So the answer is choice A. Okay. Let's do question number 16. Question number 16. It says the length of a rectangle is twice its breadth and its perimeter is 96 meter. The length of the rectangle is, okay. So we know that it is given, the relation is given between the length and the breadth. It is saying length of a rectangle is twice its breadth and the perimeter is 96 meter. Okay, and it has asked what is the length of the rectangle. So let whatever the problem is asking to find, we will let that as a variable. So let the length be x. Now it is given that the length of a rectangle is twice its breadth. So therefore breadth, it is given that the length is twice the breadth. So therefore the breadth will be x by 2. X by 2. So we have now we know the length and the breadth in terms of x, and from this length and breadth in terms of x, we know the perimeter is 2 into length plus breadth. Perimeter is equals to 2 into length plus breadth. Length is x and breadth is x by 2. So perimeter is this, and it is given that the perimeter is 96 meter. So as per the problem statement, we can now write x 2 into x plus x by 2 equals 96. So this is the equation we formed, and now we have to solve x. Now we will open the brackets on the left hand side by using distributive law of multiplication over addition, and we get 2x plus x equals 96. This implies if we further add 2x plus x, that is 3x equals 96. This implies x equals 96 by 3, that is 32. So the length we have found to be 32, and it has asked the length only. So the length of the rectangle is 32. So the length is 32, and the answer is choice C. The answer is choice C. Okay, let's see the next problem. It's also a word problem. Question number 17. Question number 17 says the ages of A and B are in the ratio 4:3. After 6 years, the ages will be in the ratio 11:9. Okay. So we know that ratio. This is you will need the concept of ratio to solve this problem. The ratio are in the ratio 4/3. So if two numbers, we know the concept of ratio is that if two numbers, let's say x and y, are there, and it is said that these numbers are in the ratio, let's say a is to b, where a and b are some integers, non-zero integers, then so x and y are some numbers, and they are in the ratio a is to b. From this we can say that x by y equals a by b. So we have to find the ages of a and b, but the question has asked a's present age is. It is asking the present age of a. So let the present age of a is x. Now from the fact that the ages of, it is given that the present ages of a and b are in the ratio 4:3. So from this fact, if we assume the present age of, also let the present age of b is y. Let's assume, we can easily find out what is y in terms of x. Now if this is so, we have assumed the present age of a is x and the present age of b is y, and also it is given that the present ages are in the ratio 4:3. So this implies that x by y equals 4/3. From here, doing cross product, we can say that 4y equals 3x, or y equals 3/4 into x. So we got the age. We assume the age of a, present age of a, as x, and we also got from the given ratio that the present age of b is 3/4x. Okay. Now it is saying that after 6 years, their ages will be in the ratio 11:9. So let's see, after 6 years, age of a will be x plus 6, because the present age of a is x. So after 6 years, the age of a will be x plus 6. Similarly, after 6 years, age of b will be 3/4 x plus 6, because we know the present age of b we have found out to be 3/4 x. So it is saying after 6 years their ages will be in the ratio 11:9. So using this fact, we can say that x plus 6 divided by 3/4 x plus 6 equals 11/9. Now to solve this kind of linear equation, where we have the LHS or the RHS fraction a term in the form of a fraction or rational number where both the numerator and the denominator has the variable x, then usually you do cross product. So by cross product, using cross product, we get the concept is from the rational numbers. If we have two rational numbers a by b equals to c by d, then by doing cross product, that is this way, we multiply a with d and multiply b with c, we say that the cross product AD equals BC. AD will be equal to BC. If the two rational numbers a by b equals c by d, then we will have AD equals to BC. Using this, applying the same concept in this linear equation, we will get, if we do the cross product, 9 into x plus 6 equals 11 into 3 by 4x plus 6. Now if we open the brackets by doing the product using the distributive law of multiplication over addition, we get 9x plus 54 equals 33 by 4x plus 66. Okay. Now we will bring all the variable terms, x terms, to the left hand side and all the constant terms to the right hand side. We get 9x minus 33 by 4x equals 66 minus 54. If we further simplify, add up the like terms on the right, on the left hand side and on the right hand side, we get 9x minus 33 by 4x is 36 minus 33 by 4x equals, this is 12. Okay. Now this implies the left hand side is 3 by 4, 3 by 4, x equals 12. This implies x equals 12 divided by 3 by 4, which is nothing but 12 multiplied by the reciprocal of 3 by 4, that is 4 by 3, and this is 16. So x is found out to be 16. And what was x? X was the age of A. And what is the question asking? The question asks the present age of A. So the present age of A is 16. It should be the answer, and we see the correct choice is B. Okay. Question number, okay, now section C. Section C, question number 18. We have 5 parts. Okay. So it's a fill in the blank. What exactly it is saying? It is asking minus 2 a square b is a, now is a, what could be the blank? I think it's a monomial, since it's a single term. So monomial. So fill in the blanks. Section C, all the parts are fill in the blanks. This was part 1. Part 2 is saying a square minus 2b square is a binomial. We see two unlike terms is a binomial. Minus 2 a square b is a single term, so it was a monomial, and a square minus 2b square, we see it has two unlike terms, so it's a binomial. Let's see part 3. It says a plus, okay, so these are all okay, so a plus 2b minus 3c is obviously a trinomial because it has 3 terms and they are all unlike. It has 3 unlike terms. So a plus 2b minus 3c is a trinomial. Okay. 4, part 4. In minus 5ab coefficient of a is, obviously in the term minus 5ab the coefficient of a will be everything. If we ignore the a, if we remove the factor a, whatever is remaining is the coefficient, so it will be minus 5b. So minus 5b is the answer. Minus 5b is the coefficient of a in the term minus 5ab. Okay. Part 5. In it is saying in x square plus 2x minus 5, the dash term is minus 5, so it will be the constant term. Minus 5 is the constant term, so the fill in the blanks will be so the question was in x square plus 2x minus 5 the dash term is minus 5, so the dash will be constant. Minus 5 is the constant term. Okay. Now section D, the final question, I guess, are true false. We have to say whether the following statements are true or false. Okay, the first one is saying in minus x the constant term is minus 1. So it is saying that in minus x, the constant term is minus 1. This is false because in minus x there is no constant. It's in minus x minus 1 is the coefficient or the numerical coefficient. It's not the constant. Minus in minus 1 in minus x minus 1 is the coefficient or the numerical coefficient or the constant factor, not the term. So this is a false statement. Minus 1 in minus x is the is the coefficient or the numerical coefficient or the constant factor. It is not a constant term. Okay. So 2, what is 2 saying? The coefficient of x square, the coefficient of x in x square minus 3x plus 5 is 3. Okay. It is saying that coefficient of x in the algebraic expression x square minus 3x plus 5 is 3. This is false because in the algebraic expression x square minus 3x plus 5, which is the term that has x? That is the term minus 3x. Please note this thing very carefully. It is not x square. The term that has x is minus 3x, not x square. And so the term is minus 3x, and so the coefficient of x in minus 3x is minus 3, not 3. It is minus 3. So this statement is false. Okay, let's do part 3. Part 3, it is saying that it is saying that 5x minus 7 minus 3x minus 5 equals 2x minus 12. So basically it is asking whether this is true or false. Now what does it mean? So we have to simplify the given LHS and see whether it is coming equal to the RHS or not. So this thing, if we simplify this, so if we can open the first bracket without any problem because it has no negative sign in front of it. So this becomes 5x minus 7. But when we open the second bracket, it has a negative sign in front of it. So its terms, the sign of its terms will change. So it will be minus 3x plus 5. Now if we further simplify this by adding the like terms, so 5x minus 3x is 2x, and minus 5 plus minus 7. So if I do it a little more step by step, so this is 5x, we add up the like terms, x terms, and we add up the constant term, this is this. Now if we add the like terms, 5x minus 3x is 2x, and minus 7 plus 5 is minus 2, this is 2. So this is not equal to 2x minus 12. So this is a false statement. This is a false statement. Part 4. Part 4, it is a similar question. It is saying 3x plus 5y multiplied by 3x minus 5y equals 9x square minus 25y square. So it is asking whether this equality is true or false. That is, whether if we simplify the left hand side, whether it is equal to the right hand side expression or not. So for that we have to simplify the expression on the left hand side. So this is a product of two binomials, and using the distributive law of multiplication over subtraction, we can write it as 3x plus 5y multiplied by 3x minus 3x plus 5y multiplied by 5y. So we have distributed the multiplication over subtraction. Now if we further simplify it, so we have two products of monomial and binomial. So if we do the product of 3x with 3x plus 5y, it becomes 3x into 3x is 9x square, and 5y into 3x is 15xy minus, over here we get 3x into 5y is 15xy, and 5y into y is 25y square. So we have 15xy plus 25y square. The first grouping symbol we can remove it without any problem because it has no negative sign in front of it. So we can write it this way. But to open the second grouping symbol, we see there is a negative sign in front of it. So it's the terms inside the grouping symbol, second grouping symbol, will the sign will change. So 15xy will become minus 15xy. Also plus 25y square will become minus 25y square. Now we will have to add the like terms. We see 15xy and minus 15xy gets cancelled out, and we are left with 9x square minus 25y square, which is equal to RHS. On the right hand side we were given 9x square minus 25y square. So this is a true statement. This is a true statement. Okay, let's do part 5. What is part 5? It is saying if A equals 2 and B equals half, then value of A square plus B square is 4 and 1 by 4. So it's given as a mixed fraction. Okay, So we have to find the value of the given expression a square plus b square. So it is a algebraic expression in two variables a and b, and we have to find the value of this expression for given values of a and b. So value of a square plus b square when a equals 2 and b equals half equals to. So we will substitute a by 2, so that is 2 square, and we will substitute b by half, that is half square. Now this is, if you do the squaring, 2 square is 4 and half square is 1 by 4, and we know that a mixed fraction, we know that if we have a mixed fraction a and b by c, this is nothing but the whole part, that is a, and the fraction part, that is b by c. So using this concept, we can say this is equal to the mixed fraction 4 and 1 by 4. This is equal to RHS, that is given. So this is a true statement. This is a true statement. So that brings to the end of the solving of test paper 7. I hope this video was beneficial, and you have you will learn something how to solve problems based on the linear equations in one variable and also algebraic expressions. So if this video was beneficial, please like it, share it with your friends, and also if you are not yet subscribed and if you are watching my videos regularly, then please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So this brings to an end to an end of the chapter on linear equations in one variable, where we have studied all the concepts, we have solved the exercise problems, and we have also solved the objective questions, MCQ, and the test paper 7. Now for further practice, I will prepare two test paper, two practice test paper, paper 1 and paper 2, that will consist of 20 questions. Some will be MCQ, some will be fill in the blanks, and some will be true and false, or some will be match the column. In those format, 20 questions, which ideally you should complete in 1 hour. I'm not sure whether I will be able to complete those paper in 1 hour, because I will have to discuss any concept required while solving any problem. But you should be able to complete those test papers in an hour. I will but tomorrow I will prepare the first test paper, that is test paper number 1. So be prepared with all the concepts you have learned from the chapter linear equations in one variable and also algebraic expressions. You can watch my videos in the same playlist if you want to have a good understanding on these chapters. It will be good enough to solve the test papers. So stay tuned for the two next test papers. There will be two test papers, test paper 1 and test paper 2, that will give you a good coverage of all kinds of problems that can come from these two chapters, that is linear equations in one variable and algebraic expressions. So thanks for watching, and until the next video, take care and bye.